Hello everyone, and welcome to my 12th tutorial on how to create full-stack web applications. In this tutorial, I'm going to be focusing on authorization and authentication using Spring Security. Now, in order to illustrate the usage of Spring Security, I've added some basic features to our front end, the ability to create blogs for particular accounts, so that I can illustrate authorization using Spring Security after we authenticate a user. So to illustrate this, I'm going to create an account here, and I'm going to call ABC. And now I'm going to go to Search Accounts, and you can see that there's an account here called ABC, and I can click this button to manage it. And now I can create a blog for ABC, so I can write down something like cooking blog. And now I can click Create New Blog. So this will create a new blog for ABC. And now I can go to Homepage, log out, create a new account. So I'm going to call this DEF. And the problem here in our application is I can go to Search Accounts and go to the blog for go to the account we originally created, ABC, click Manage, and now I'm managing the blogs for ABC, and I can create something like an auto blog, something like this, and you can see we can create a blog for another account while we are logged in as user DEF. So this is an example of an unauthorized application, and we would like it that the application only allows creation of blogs for ABC when you're logged in as ABC, or maybe if you're an admin, it allows you to modify those blogs. So to do this, I'm going to first add some dependencies to our application. There's a couple basic dependencies you need in any Spring Security application, and it's the Spring Security Web Artifact and the Spring Security Config Artifact. Additionally, there are two other dependencies that I'm including. The Aspect JWeaver dependency, which will basically allow us to create an AOP point cut, which will allow us to whitelist our RESTful endpoint. And you'll see later in the tutorial how that will be helpful and make our application more secure. And I also noticed there's a compile time dependency on the Servlet API, so I've also added this dependency. So you can see these are the 4 dependencies you need to add to your project. This one, and these 2 down here. So after you add those to your POM file, it's a good idea to right-click your POM file, go to Maven, and click Re-import so that they're initialized on the class path, and IntelliJ IDEA downloads them. And after you do that, so what we want to do here is we want to set up a basic Spring Security application and illustrate the default configuration of Spring Security and how that works. So I'm going to go over tutorial here, and I'm going to create a package called Security, and I'm also going to add component scanning for that package. So I'm going to go to our businessconfig.xml, and I'm going to scroll to the bottom here and copy this tag here, this component scan tag, and I'm going to scan tutorial.core.security. So now we're scanning the components in the security package, and this is where we're going to store our security configurations. So the first class I'm going to make is going to be a class that extends Abstract Security Web Application Initializer, and this will tell Spring to basically set up the Spring Security filter chain in our servlet container. So I'm going to create this class called Security Web App Initializer, and I'm going to extend Abstract Security Web Application Initializer. And so this is all you need to tell Spring Security that you want to set up the Spring Security filter chain on all URLs. So this enables pre-processing of the request before it reaches your servlets, your controllers, or your static resources, so that Spring Security can override the response if it has to and output an unauthorized status code or something like that if need be. And I'm also going to add here a class called Security Config, and this is going to be annotated with the @configuration annotation because it's going to we're going to inject beans into this class. as we configure Spring Security. And I'm also going to add the enable web security annotation to turn on Spring Security. And I'm also going to extend the web security configure adapter class. And this includes some default configurations in our environment for Spring Security. For one thing, it sets up a form-based login on all URLs and forces authentication, and after authentication grants access to resources by default. We'll be changing that later in my application to more of like a whitelisting approach in our application. And so I'm going to also auto-wire a bean here, and I'm going to call it config authentication. Let's see, I'm going to call this, so basically, let's see, I think it's Authentication Manager Builder, so config auth builder, Authentication Manager Builder, there we go. And this is a class that lets us set up user login. So we can set up users from our database. We can use the adapter pattern so that we can take users from our database and convert them to Spring Security users, so that during the login process it uses our username and password of the users from our database. But for now, we're just going to add an in-memory authentication scheme so that when a user comes to so just for basic illustration. So I'm going to select in-memory authentication, and I'm also going to select with user, and I'm going to specify username and with password, and roles of user. So this is just to illustrate Spring Security's in-memory authentication builder, and this is throwing an exception here, so you may want to make sure you add that exception to the function here. And now I'm going to also, now I'm just going to run the application, and we should be prompted for authentication when we access any URL on our website. So I'm going to restart this application now. And if I go to our website here and I do empty cache and hard reload here, we should be prompted with to authenticate. And let's see, we might have an error here. Okay, so we have an error, and there's no Spring Security filter chain defined. Basically, if you get an error like this, sometimes it's a good idea to clean the project just in case before you go hunting for a bug, because sometimes it can be an incorrect state, in a deployed state. So I'm going to run this application again. Let's see if it runs. Okay, so it runs, and let's go to the website. Alright, so we're getting the error again. So let's see what we're doing wrong here. So we have a business config set up, and we're scanning the okay, so basically we're scanning for components in tutorial.core.security, and our security package is outside of the core package. So I'm going to drag this into our core package, and now everything should work. Okay, so now our security package is in our core package. I'm going to restart the server now. Now if I go to our index.html, we should be prompted with a form to authenticate. And you can see this is the authentication form. And I'm also going to inspect view page source firstly. And you can see that this form is posting to a URL called basic-web-app/login. And additionally, if I click inspect element and I go to the network tab, let me record this. So I'm going to go to app/index.html, and so you can see that what happens when we go to index.html, 302 found status code is returned, which is basically a redirect in the HTTP spec, and we're redirected to the login page over here. And then we get a status code of 200 in the response. So we redirected to the login form, and then we also, when we enter data into the login form, it's posting to a predefined URL that Spring Security has set up for us. So everything here is Spring Security's default configuration, and I can enter incorrect username and password like this, and you can see that when we enter the incorrect username and password, we're redirected again after we post that to the URL, we have a FreeR2 fan, and we're redirected to login with a parameter of error to render the error message. Additionally, if we enter the correct username and password, so if I enter username and password, we're logged in successfully, and all the resources are the original request that we made before we got redirected to the form is sent again, and the website is rendered. So this is a default behavior of Spring Security, and we'd like to override that and basically make our application work more because we're going to secure a RESTful endpoint. We would like to change the way we would like to change some of this behavior. For example, when we post correct username and details, we would like it to, instead of repeating the original request, to send us a status code of 200 OK and be done with it. And additionally, if we go ahead and we enter the incorrect username and password, we'd like it to send back an unauthorized status code. So and also for redirecting to the form, instead of when we access a resource that we're not supposed to access, we would, or that we're not authenticated to access, we would like it that the form that we're not redirected, but instead we're sent an unauthorized status code. So to do this, we're going to have to subclass 3 classes, and one of them being an interface. The first class, 2 classes we're going to extend are the simple URL authentication failure handler and the simple URL authentication success handler. So I'm going to create these 2 classes in our security package here. And you'll be able to see basically as we develop this, I'm going to record the requests and responses to the server using Chrome's network tab here. And we'll be able to see, as we add these features, the correct behavior will be added. So I'm going to first create a class called authFailure, and I'm going to extend simple URL authentication success failure handler, and I'm going to override a method here, and I'm going to override the let's see here. Okay, so on the authentication failure is the method we're going to override, and this allows us to send a response after a user has authenticated, but after a user has tried to authenticate but failed, we can change status code in the response. So I'm going to, in this response here, I'm going to take the response, and I'm going to type set status to HTTP servlet response of unauthorized. So unauthorized is the standard HTTP status code that you send when a user has not authenticated to access a particular resource. And for authorization, you use the forbidden status code. So if a user is authenticated, but the server has decided that this particular user is not authorized to access a certain resource, you send back a forbidden status code. But in this case, I'm going to send an unauthorized because the user is just trying to authenticate and has failed to authenticate. Additionally, I'm going to create a class called before I create the other class, I'm going to also add the component annotation here, and this will ensure that this class becomes auto-wireable into our security config class. And I'm also going to create a class called authSuccess, and I'm going to also add the component annotation, and I'm going to have it extend the simple URL authentication success handler. And I'm going to override the method onAuthenticationSuccess, and I'm going to change the response to send back a status code of HTTP servlet response dot OK. So this is the response we want to send back if a user has successfully authenticated, and this will be helpful when we're creating in AngularJS the function to log in the user using form-based login to correctly be able to handle errors and things like that. This will make that much easier. Additionally, because we're using form-based login, there's a session cookie that is set. And so basically it will be important, as you see later in this tutorial, to set that session cookie and basically have an authenticated session with the server that can time out. And this is actually a much more secure approach than, for example, basic authentication, because the session times out after, I think it's about a half an hour on Tomcat servers. I might need to be corrected on that, but basically the session should time out, and basically it's more secure because a hacker can, for example, read the local storage for the username and password. And I'll show you that as we develop the front end of this application to log in. But for now, we're just going to secure this endpoint. And if I go ahead and run the application now, you should see these status codes have changed, and the behavior of the application will change, but I just remembered I do need to auto-wire these and insert them into our configuration. So I'm going to auto-wire auth failure here. And I'm also going to auto-wire the auth success object. And I'm going to inject these into our application. Now, before I inject, I'm just going to configure Spring Security the way Spring Security normally works. So I'm going to override this particular method here. I'm going to override configure HTTP security. And now, after you override this particular method, it basically ignores some of the defaults that Spring Security has set. So this has basically stopped the default configuration, which is to set up a form-based login. And if I actually access any URL right now, if I restart the application will be pretty much completely unsecure. So I can go to a URL here, like index.html, I'll be able to access that. Let me just do a hard reload to be sure that works. So yeah, basically I can access this page, and basically normal Spring Security is not working. So first I want to add the default configuration that Spring Security has set up, just to be in line with the way Spring Security does things, and then we'll add our changes. So I'm going to deviate a little from standard Spring Security configuration. I'm going to disable cross-site request forgery protection, because it's going to interrupt the tutorial, the ability to illustrate certain things in the tutorial. And I'm also going to authorize I'm also going to add form-based login by doing this. And I'm also going to authorize any requests that to the site by doing this. And so this should basically force authentication on all URLs. So if I restart our application now, it should behave mostly the same way Spring Security normally does. And so I can go to index.html, and it should force authentication. Let's go. Okay, so we're getting an error here. Let's see what we're doing wrong. Oh, I do need I think a permit all requires authentication here. So for authorized requests, I'm saying for all ant matches of this URL, I want the user to be authenticated. So that should be correct now. Let's see if that fixed it. Okay, so if I go to index.html, okay, let's see. Okay, so the form is rendered, and basically I can enter incorrect username and details. And you can see it sends us to the error page, and if I enter username and password, we are logged in. So when we're logged in, a cookie is established with the browser. If I go to resources here and go to cookies, and then localhost, you can see there's a JSession cookie here, which Spring Security is set. And so now we are in an authenticated session. So that's what I was talking about with the cookie. This is I think it should time out after half an hour. Correct me if I'm wrong. And basically, that is the cookie that Spring Security has set. Now, I'm going to change this so that instead of redirecting us here, it just sends us a success, an OK status code, so a 200 OK status code upon successful authentication. So in order to do that, I'm going to go to the form login clause here, and I'm going to add success handler, and I'm going to add in this auth success object we've auto-wired. So I'm going to add auth success, and if I go ahead and run the application now, you should see the response is correct, what you would expect. And I'm going to go to our index.html page here. Now, if I enter incorrect username, if I enter incorrect username and details, let's say incorrect password, you can see it sends back basically the normal response for a login error. However, if I enter say username and password, now instead of sending us a redirect, which it normally does, it should send us a status code to OK. So I'm going to erase this log just to illustrate this, and I'm going to log in now, and you can see a status code to OK is sent and a blank page is rendered. So this is the desirable behavior when coding against a RESTful endpoint. You want to be able to authenticate with the server and just have a 200 status code sent back to let your RESTful client know that you have successfully authenticated. Now, I'm also going to add the failure handler because we were getting a 200 OK on incorrect details, and we would like to send back a status code of 401 unauthorized. So I'm going to add failure handler here. I'm going to have auth failure here. Okay, so now that I've added this, we should have, it should work correctly for incorrect details. So if I go back to say app/index.html, you can see it redirects us, and if I enter incorrect username and details, instead of sending us 200 OK and a redirect to the login's error page, what we should have here is a status code of unauthorized and an empty page. So if I erase this and I click login, you can see that we get a 401 unauthorized exception, status code, and and also an empty page. So this is the desirable behavior for a RESTful endpoint. Now, there's still one more thing we need to do, and we need to implement the Authentication Entry Point class so that we can override the redirection that Spring Security is performing for us. So Spring Security does two things with its default implementation of Authentication Entry Point. What it does is it first records the request you've made before it redirects you to the login page. Then it redirects you to the login page, and then after you successfully authenticate, it repeats the original request you made, and sends back the response. So we're going to override this because if we access a resource that we should be authenticated to access, and the desirable behavior in a RESTful application would be to just send back a status code of unauthorized. So in order to do this, I'm just going to create a class here called Entry Point Unauthorized Handler, and I'm going to extend the implement the Authentication Entry Point class, and I'm going to generate this method, and in response, I'm going to send an error of HTTP servlet response of unauthorized, and also access denied message. So if I go ahead and I restart our, I also need to wire this into our security config, and before I can wire it, I do need to add the component annotation. So I'm going to add this component, and I'm going to go to our security config here, and I'm going to add auto-wired private security, entry point unauthorized handler. Okay, so here we have our unauthorized handler, and I'm going to add that to our to our default configuration here. So I'm going to create a clause called exception handling, and in exception handling, I'm going to add authentication entry point with this function. And I'm going to add this unauthorized handler here. So unauthorized handler, and I'm going to end that clause with the AND function. So now that I've added that, when we go to index.html, instead of being redirected to the login page, what it's going to do is it's going to send us an unauthorized exception. So if I go here, and I go to app/index.html, you can see we get a 401 access denied with the message access denied, and here it is recorded. So we're getting the correct response. Now, there is one problem. We are basically applying this to all URLs. We would like to just apply this to our RESTful endpoint. And there's other ways of, if you do have static resources you need to protect, Spring Security definitely has capabilities for that. But in this tutorial, I'm just going to show you guys how to secure your RESTful endpoint in our application. So to do that, I'm going to before I illustrate the authorization of the correct authorization of our application, I want our application to be able to correctly log in and authenticate as users. And so to do that, I'm going to create a login form for AngularJS that we can log in to the basic web app /login URL that the form was originally using, and also make our Spring Security use the same database of users that our application is originally using. So to do that, I'm first going to add user details to our application. First I'm going to add user details to our application. So basically, this is an adapter pattern in Spring Security that allows you to translate your users to Spring Security users so that you can perform authentication with your user base. And so right now we're using in-memory authentication, which is basically an in-memory database of users. What I prefer we do in this application, what you'd want in a real application, is have this connect to a database. So in order to do that, you're going to want to add I have actually two classes already created here, just to speed things along a little. I have a user details service implementation and also account user details, which is a subclass of the interface. And I'll show you exactly what these do in a second here. So account user details implements Spring Security's user details class, and we provide the methods for getting, the most important methods here are the username and password, which Spring Security requires to authenticate the user. And you can see we're getting that from our own account object here. So this account is the account we created in an earlier tutorial, and also we're giving this user a role of user here in the granted authorities. So we also set reasonable defaults for the other functions here, and for the user details service implementation, we auto-wire the account service to retrieve accounts. And when Spring Security loads a user by username, because it needs to authenticate a user, it's going to grab this function will grab a user from our database and create the account user details to adapt our object to the Spring Security object. So this is how you set up This is how you set up a database-based authentication using Spring Security. And I'm going to go to our security config to basically add the proper configuration for this. So private. So we're going to want to auto-wire our user details service implementation. And also, I'm going to go to our builder here, and I'm going to type user details service, and going to add type service here. So instead of having service, I'm going to call it user details service. Okay, so all right, that sets up our user details service here, and so accounts should now be grabbed from the database. So when a user registers a user, it will save the user to the database using our REST API as before. However, let's see. All right, I had a typo there or something. So basically, it will save the account as it did before. However, when it logs in, it's going to use this user detail service. Now, there's one more thing we need to add, which is the AngularJS script to log in using form-based login. So I'm going to go to our web app here. I'm also going to start grunt to the grunt watch task here. Okay, so the grunt watch task is starting up here. Okay, so it shouldn't take too long. Okay, so now it's running, and so I'm going to go to our source directory here. I'm going to go to account and go to account.js, and in the account session service here where we log in, I'm going to change this code. So right now you can see we have a data name and we have the username and password here. So when a user logs in, we store username and password in local storage. So this is insecure. You shouldn't be doing this because what can happen is if somebody, after you're using the computer and you log in with your username and details, say we're doing basic authentication, and we send the username, we record the username and password in local storage to establish a session so that we can authenticate in later requests. This is going to be insecure because after you log off, if you don't clear this, what can happen is another user can read it. In addition, this data can be read in a cross-site scripting attack, and so it's much safer to store a temporary session cookie that is temporarily authenticates the user. And so I'm basically going to do that. So I'm still going to store the logic for is logged in, log out, and log in. However, I'm not going to be storing the username and password in local storage. So instead of setting it to data, I'm just going to set it to an empty JSON object. And I'm going to only conditionally set this local storage upon successfully logging in. So I'm going to change this function to return a promise, and the promise will enable us to do different kinds of logic after the fact, after the user is logged in. So I'm going to, so you can see we've injected the HTTP service here. I'm going to return http.post, and I'm going to post a basic web app/login. And I'm also going to set our username and password here in data. Now this data is going to be URL encoded. So it's important that you use the syntax for URL encoding, which is variables separated by the and sign. And so I'm going to have this set to data.name and plus, and so here's the and separate variables, password equals plus data.password. And so that's our data field there. And additionally, we're going to set headers, and the headers we're going to specify that the content type that we're setting is form encoded. So I'm going to specify a header here. Okay, so that's said now, and I'm also going to specify a promise here. And I'm just going to end this call and make sure we don't have any syntax errors. Okay, so we do, let's see. Oh, okay, it's the local storage that's throwing an error. Well, we'll fix that in a second here. All right, so upon success, we want to alert that login is successful. And also copy and paste this local storage set item into here. And you can see we're not storing any specific username and details in the session. And you might want to attach, there might be a way to, there might be a better way of doing this, maybe using cookies or something, or reading cookies from AngularJS. But basically, I'm just going to do this for now. And so we alert successful login upon a success, and also I'm going to add a function for an error, for example. Say the server sends back a unauthorized exception or something like that, status code. I'm going to alert error logging. Okay, and I'm going to erase this here. Okay, so that should work for that. Now you can see we're returning. We write dot then to create a promise, and we return the promise. So we can add additional functionality, execute additional code after these functions are performed. So I'm going to do that. I'm going to go to our user exists function. I'm going to go to the login controller and register controller, and I'm going to chain additional logic. So over here, upon successfully logging in, only upon successfully logging in do we want to redirect the user to the home page. So I'm going to write dot then. I'm going to specify a function here, and I'm going to add in this code and place it in here. So now on success, it's going to redirect to home. And for registration, we're basically going to do the same thing. So we're just going to copy this code here and paste it down here. Okay, so basically registration form, upon registering a user, it's going to try to log in the user, and then upon successfully logging in, it's going to go to the home page. So if I go ahead and let's restart this application to make sure our user details are corrected, our new classes, and everything's up correctly. So I'm going to start this application now. And hopefully we don't get any errors. Now if I go to our basic web app /app/index.html, it's going to actually redirect us to, it's going to send us unauthorized exception, because we're basically, we need authentication, but basically we need to permit all URLs to have a whitelisting approach. Let me go to our security config here. So we're asking that all URLs be authenticated. Now I'm going to change this so that we permit all users, and we're going to do method level authorization in a moment here. But I'm just going to make sure that all our code, as we've added it, is working correctly. And we're just going to restart this. So I'm just going to make sure that we can register users as we did before, but this time using Spring Security users. And so I'm going to go to our index.html page here, and you can see we go to the page here. Looks good, we don't have any errors. I'm going to go to register here, and I'm going to create an account called ABC. If I click register now, it should use the additional code we've added, and hopefully everything works correctly and we get a successful registration login. So I'm going to click register here, and you can see login successful. And so now we're logged in, and we have that session cookie set. So we have a new session cookie set because that because we just logged in. And I guess I can illustrate that. So let me go to localhost here. So we're just going to clear our local cookies here. So no cookies. This site is set no cookies. So if I go to the login form here, I type let's say EFG, and I click register. Login, it says login successful, and if I go click this tab and then click back to refresh localhost cookies, you can see a session cookie has now been set. So we have an authenticated session with the server, and I can go ahead and click log out, and you might want to actually clear the session cookie upon logging out, and we don't do that. So that would make it more secure application. Now, if the same problem still exists, I can still go to search accounts, and if I'm logged in as ABC, I can create blogs for EFG. So we're going to change that and add some authorization. So I'm going to go back to our application here, and I'm going to go to our controllers here. So I'm going to go to REST, MVC, and then I'm going to go to our blog controller. Actually, I'm going to go to our account controller. And so you can see I already have some commented out code here. And this is code to programmatically check that the user is the owner of account. Now, there are other ways to do this using annotations, but I'm just showing you guys how you can programmatically check the principal, which is the currently logged in user, to see he has access to the account. So this code is fairly self-explanatory. We just grab the basically when Spring Security logs in a user, the Spring Security context, this object that we're getting, is populated with an authentication object, which holds the principal user. So I'm just going to import this class here. And so we're grabbing the principal class, and then we're checking, is it an instance of user details? If it is, we're going to cast it to user details and then grab our account out of the database that's correlated to the Spring Security user. And if the logged in, this is the logged in user, if the logged in user has the ID that's equal to the resource that's modifying, so this is for blog creation, we're making sure the owner, that this is in fact the owner of this account, so he can create a blog. If that is the case, then we're going to perform the logic to add the blog. So I also have added a forbidden exception, and this, if I control click this, you can see it just responds with forbidden, which is basically this user means all of this user is unauthorized to access this resource. So it throws that if the user is in fact unauthorized. And so if I go ahead and restore this application, you should be able to see that basically only the owner of account can modify the blog entry, the particular blog. So now our application's starting here. And I'm going to go to our page now. Okay, so I'm going to go to register. I'm going to close this. I'm going to go to register. I'm going to create an account called ABC here, as we did before. And I'm going to go to search accounts. I'm going to create an account for ABC, let's say cooking blog. And so cooking blog is created. Now I'm going to log out, and I'm going to log in as user DEF. I'm going to. So all right. So this is actually a bug. We actually wait. Hold on. I think that's a bug. Hold on. All right. Somehow account was registered, but basically account was registered, but our applications should still work to illustrate the example. Basically, DEF is created here, the account, and I'm going to log in as DEF here. All right. So we're logged in as DEF now. And I'm going to go to search accounts, and I'm going to go to manage for the ABC blog. So I'm going to click manage, and now I'm going to create an auto blog here. And if everything works correctly, we should not be able to make this create this blog. In fact, a 401 unauthorized status code should be sent. So I'm going to click inspect elements so we can look up a network tab, and so we can record the 401 unauthorized. So I'm going to click create new blog. So we're managing the blog for ABC, and we're logged in as account DEF. So we should not be able to make this auto blog here. So I'm going to click create new blog, and you can see a 403 forbidden is sent, which is the correct status code. I accidentally set 401 unauthorized. The correct status code sends 403 forbidden, and that is working properly. So that is working properly. Now let's see, yeah, that's working properly. Let's make sure we can create accounts for DF. So I'm going to click manage for DF, and I'm going to click blog for DF, and this should work. So you can see everything is working as expected. Now, there's a lot more you can do with Spring Security. You can, for example, there's pre-authorized annotations, which allow you to check the role of the user and do a lot of other stuff. We're going to be using pre-authorized annotations to whitelist the URLs of our RESTful endpoint. So basically, by default, the user, once they authenticate, has access to all our RESTful endpoint functions on our controller. And what we would like to do is basically explicitly permit the user to access the URL make it so that we have to explicitly grant access to a particular URL. So all URLs are protected by default, or restricted by default. So to do this, I'm going to go to our webinf directory. I'm going to go to web.xml, and MVC dispatch for that. And if you scroll down here, you can see I'm using the security namespace here and creating an AOP point cut to apply the access rule of a requirement of dummy to the execution of all RESTful methods in our MVC directory. So basically, This means that you have to have the role dummy to execute any of the functions on our controllers. And basically, no user will have the role dummy. So by default, this will deny access. However, if you have a pre-authorized annotation that says permit all or permits particular users, if that passes, this won't be evaluated and access will be granted. So this is effectively a whitelist in our application. So if I add this, and if I add this and I click stop here and I restart the server, you should see that we're denied access to, for example, create accounts and things like that. So I'm going to start the server now here. So if I go ahead and click empty cache and hard reload, just a habit of mine. So I'm going to go empty cache and hard reload here, log out here, and so if I go to search accounts, you should see that it says 401 unauthorized. If I try creating an account, it's going to say unauthorized. So basically, we're unauthorized to access the URLs we normally do. Well, to allow access to the methods that we consider public, we need to explicitly allow access. So I'm going to go to account controller here, and I'm going to uncomment all of the ones necessary to run our application. So I'm going to uncomment this pre-authorized annotation to permit access to finding all accounts. And likewise, I'm going to do this for the other methods here. And I'm going to go to blog controller and uncomment this permit all here for finding all blogs. And if I go ahead and run this application now, it should work, and we should be able to do everything we did before. But now we have a whitelisting in our application, which is a much more secure approach. And so let's try. So I'm now going to go to our index.html here, and I'm going to create an account here, ABC, and you can see login successful, so that's working. There's accounts here. I can create blogs. So everything is working, and this is a pretty good approach to securing your application using cookie-based authentication with Spring Security, a whitelisting approach, which will make your application much more secure. And there's still a lot you can do to improve this application. There might be some bugs in it that need to be worked out, but this should get you guys started to making your own project that's enabled with Spring Security. Anyways, I hope you guys found this helpful. If you did, like, comment, and subscribe, and thank you for watching.